All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we did start our malaria model subclass and module. Let's have a look at what we went over today. Now, today was a pretty light note-taking day. I just wanted to bring over everything that we needed for the actual module, all of the imports and all of the data. So as you can see, we have that here. We have our imports here that we're going to need. Of course, we have the data that we have accumulated so far that we need to run to actually get our models. And then also had to bring over our actual models that we were working on in the last module. I brought everything over and I structured it properly so we can see what's what goes where, what gets broken down into what. So let me go over that really quickly. I'm actually start compiling now since we're going to actually take a look at those models, get that out of the way. So you can see here we have our first four models. It's going to be our whole model here with the func input. You can see here starting at line 82 with our carve Ds and our max pool 2Ds. This is going to be our extract information. Then we have our classifying information, which is the dense layers and the flattened layer. So that's going to be our whole model here. Then I actually have that separated by these hashtags here. And this is going to this next part is going to be just our extractor information. As you can see, we have our func in it and just our carve 2Ds and max pool 2Ds. So this is just going to be our extractor information without the classifying information. So this is going to be our extractor right here. And then our last model should be the extractor information condensed down into our feature extractor model function. And then we're going to add that with our classified information, as you can see here with our dense layers and our flattened layer. So yeah, we should get back three models as a whole. We should get back a whole model first, then we should get back the extractor model, and then we should get back a whole model with just the feature extractor model taking the place of the carve 2D and the max pool 2D information applied with the classifying information. So that's what we've done so far, and we did take some light notes. So let's get in pick up with some reading. So this is for the model subclassing module. So it's important to note that model subclassing permits us to create recursively, what is that, composable layers and models. Now, what does that mean? This means that we could create a layer where its attributes are other layers, and this layer tracks the weights and biases of the sublayers. Before making an example, let's get this import. We're going to import layer from layer, see line 106. Let's go back to 106 really quick. Not 106, line 6. Let's go back to 6 really quickly. So you can see here, line 6, we inputted this layer so we can actually work with the subclassing and use layers. So yeah, we had to import this. And we had to import this to our caress.layers from caress.layers. So that's what that is there. Let's go back down to our reading. And we started compiling good. Now we can create our model using the model subclassing. Now that we have our import. Now with all that done, we can start with our feature extraction function. This will inherit from layer. So it's supposed to be I don't know what was going on with this. So it will inherit from TensorFlow layer. Next, we will have an init method followed by a call method. The call method is going to be commented out right now because we're not actually using the method or the model subclassing as of now. So I have that commented out. If you see it, don't get alarmed by anything. It's just commented out because we're not using it at the moment. Next, we can copy the feature extractor that we recently created and paste it into our subclass model minus the model equals model in the model dot summary. So I'll show you that also in a second. Next, we will add a super function and pass in as parameters, feature extractor, and self. Then we will add a .init method. So this is our subclass or our sub multi-class here. You can see here we have a class, feature extractor, the layer passed in. Then we have our init method here with self. Then we have our super function with the feature extractor and itself. And then we have our .init method again. And this is the call I told you about that we're not using at the moment. So we have it commented out just so it doesn't give us any hiccups. And then we have here our function, our feature extractor, copied and pasted down minus the model in the model summary. So that's all that there. So that's basically how far we got. We didn't really do any new coding or any new modeling. It's just the same old stuff. And I just brought it over and ran it to make sure everything lined up perfectly and we are capable of moving forward without any hiccups. So we're going to go ahead and make sure that our models came over correctly. Like I said, we should have all of our previous information. Plus, we should have our three models, one whole model, a feature extractor model in the middle, and then a whole model at the end. But first, let's go through our images. Remember, we have 16 images that we're dealing with. Of course, we're going to bring all of our old information over so we can build off the top of that and move forward. So we're gonna go through our 16 images. I don't know what the hiccup is with the images. All I have to do is produce images. Okay, we're going through those. And it's a good thing we only have 16 to get through, and then we can actually finish compiling without doing anything else. It'll compile automatically. You don't have to interact with it again. Okay. Okay, and that's that. Now we should have our models. Now let's take a look and make sure that we have everything that we need and everything came over correctly. So we should have three. Let's count them here. We have our. I'm gonna start from the top here. You can see we have our first Lynette model. This is our whole model here. As you can see, we have our COV 2D information here. We have our classifying information here with our flattened layers and our dense layers. So this is our first whole model. And you can see we have over 46 million total parameters, 46 million and change trainable parameters, non-trainable parameters are 2,244. The next layer should be our extractor. Let's see if that came through. And as you can see here, it's labeled feature extractor. So this is just our extractor model here, as you can see. You can see our output is 54 by 16. So this is our extractor data here. We don't have any classifying data, meaning there's no flattened layers and no dense layers. So this is just our extractor information. Total parameters 1,136. Trainable parameters 1,092. Non-trainable parameters 44. And our last model should be another whole model, but this time with the feature extractor instead of the COV-D. So as you can see, we have that here. So this is another whole model here that we have. And this time we have our feature extractor, which takes place of our COV-D information. So we cut all of that out and condensed it now into our feature extraction function. And this is what we have, 16. We apply that with our classifying information. You can see we have our flattened layer and our dense layers. And again, it brought back our whole model again for us. 46 million total parameters, 46 million and change trainable parameters, and 2,244 non-trainable parameters. So everything came over correctly, and we are able to move forward, and we will pick that up tomorrow with our model subclassing. So yeah, of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.